Hello and welcome to Exploring Global Problems, a podcast where we talk to academics from Swansea University whose groundbreaking research is tackling global challenges from health innovation to sustainable futures and the environment, from digital technologies to clean energy. My name is Sam Blaxland and today I'm joined by Mary Gagen, Professor of Geography at Swansea University. Her research explores issues surrounding climate change and how this impacts the planet's forests. In particular, she researches the long-term trends of the global climate by examining the records of ancient trees. This has taken her around the world, from the Arctic to Borneo. Professor Mary Gagen, welcome to Exploring Global Problems. Nice to see you.
Thanks so much. Thank you.
Obviously, your research surrounds one of the biggest debated topics in the world now. Can you just, to start us off, explain what the issues are and give us an overview of where your research fits into that?
Yes, absolutely. So like you said in your very nice introduction, I work on a very specific part of climate science, which is looking at natural archives of how our climate has changed in the past, because they give us some context, really, some long-term context for what's happening in our climate now. So if I wanted to find out what had gone on with the weather over the last week, the last year, actually up to the last 100 years, I could look at meteorological records from weather stations. And that would tell me how our climate's changed in that time frame. But to go back further than that, we have to look at something in the natural world that archives information about climate. And tree rings are amazing at that. We've all seen the stump of a tree, rings inside it. I look at the climate information stored in those rings.
And by looking at those rings, what does that tell us precisely?
So tree rings are actually this incredible compiler of all kinds of different information. Most people, if you tell them, I work on tree rings, they say, okay, I know the width of the ring is related to what the weather was like. But the density of the wood and how the chemistry of the wood changes from year to year gives us a way into all these different parts of how our climate has changed as well. Understanding how the temperature is changing on the planet is really important, but we need to understand our climate system is comprised of rainfall and cloudiness and how humid it is, how intense that rainfall is. So because trees are a natural living product, they're sensitive to everything in the environment. And we can look at many different variables to build up a truer, more complete picture of climate change. And what we find out is increasingly alarming. So the main kind of time period that tree rings can tell us about are the changes that have happened in the last few thousand years. We can go back up to 10,000 years using building materials, so the rings in timbers from buildings or trees that have fallen into lakes or ended up in a peat bog, and we can fish them out and go a really long way back in time. But it's really the last couple of thousand years, which is useful because that's the context that we're living in now. So we can look back at periods when it was a little bit colder than it was now, a period known as the Little Ice Age, sort of 15th and 16th centuries. A period in the medieval, which was much warmer than it is now. It's changed its name as we've studied it from the medieval warm period to the medieval climate anomaly, precisely as we've learned from trees and other archives that it was more variable than just warmer. So they really give us a chance to build that picture of looking at past climate. And they have two huge advantages. There are trees across much of the world. So it's like you've got a little weather station anywhere where there's forests. And also we can date each ring. So if I find something out from a forest, say in Scandinavia, that there's a super narrow band of wood in a certain time period, I can give a date to that year. We can, what we call, absolutely date them. So those are their two advantages, really.
And I promise I'll pick up on all of those things in more detail as we go along. But is what you're describing, is this paleoclimate science? Or is that something else?
Yes. So that is exactly what we are. We academics love words, don't we? We love phrases. And I would be described as a climate scientist, a paleoclimatologist, or a dendroclimatologist. And all of those come under my umbrella of I'm a geographer. So yeah, paleo obviously means old. Climatology is the study of our climate. So the people who fall under that umbrella heading of paleoclimate scientists tend to work on these archives of natural climate change. In my case, trees, but that could be ice cores or lake cores or some super weird stuff. There are marine shells, marine bivalves that have rings in them, the same as a tree. There are people that work on those, people that work on stalagmites and stalactites. They can tell us what the climate was like in the past. So we all fall under this little umbrella of paleoclimate.
So with the work you do on trees, just talk us through the practical things you do. I mean, even just how you collect a sample from a very large tree.
From a tree, yeah. So obviously, when we want to look inside the tree trunk, we don't want to fell a tree. We rarely do that. Sometimes trees fall down, wind blow, that sort of thing. Like I said, when we're fishing trunks out of lakes or bogs, we're using the whole stem. But generally, we want to take a small piece about the size of a pencil out of the side of the trunk, and we use something called an increment borer. So you ever seen anyone testing whether a cheese is ready to be eaten?
Oh, yes.
Yeah.
I like cheese.
Bit like that. It's made actually strangely from the barrel of a gun, a 5mm gun barrel that has a screw on the end of it and big handles, and we twist that into the side of the trunk and pull out something that looks an awful lot like a pencil. It's a radius of the trunk, and you can see the rings all the way back, and we use that little piece of wood.
Use it to do what?
So the first thing we would do is some polishing and sanding in the lab to put a nice surface on it so that you can see the rings. We would then measure the width of the ring. We would assume if it was a living tree that the outer ring is this year's growth or last summer's growth if we were coring in the winter. And then we would measure the width back through time, and we would pattern match with other trees from the same forest so that we were able to give an absolute date to that core that we just took from a tree. And we would slowly build up through time. Those are called master chronologies, those ring width series from many, many trees. And they're super important because they let us do that absolute dating where we can say for definite, this ring is this year. They give us that kind of statistical rigor to what we're doing. And if we were working on just the ring width record from that particular forest, we would stop there. But if we wanted to look at the density of the wood, we would do something called X-ray densitometry, where we actually took an X-ray film and looked at the density of the wood and how it changes through time. And then what we're particularly known for in our tree ring group at Swansea is looking at the chemical changes from year to year. And if we wanted to do that, things get a little bit more technical. We would chop each ring into a different little pot. We would do some wet chemistry on it to take out resins and waxes and those kind of less homogeneous products in the wood. And we would take each year's sample from that little pencil core down to just the cellulose. So when you wallpaper walls, that fluffy wallpaper paste is wood cellulose. That then would go into our analytical chemistry lab, and we would use a machine called a mass spectrometer to look at the different types of oxygen, carbon, and sometimes hydrogen. And that would tell us a whole bunch of new stuff. So the thing I find really interesting about tree ring science is it starts with sandpaper and it goes down to, really expensive bits of analytical kit.
Yeah. Just for context, when did people start collecting temperature data rigorously, organisations like the Met Office?
So we're really in the part of the world here in the UK where we have the longest climate records. We have about 100 years of instrumental data, so from weather stations. But we also have something called the Central England Temperature Record, which actually goes back nearly 400 years because we've slowly patched together old thermometer records and observations and that kind of thing. But for much of the world, and particularly from places where our climate is changing fastest, we have a really scant picture. Parts of Africa, we have maybe 10, 20, 30 years of climate data. If there's been conflict in areas, that data will have breaks in it. So as soon as we leave the old world, we start to lose any information, any visibility back beyond the last few decades. So that's where we really, really need to rely on paleo records to give us that longer term picture.
And of course, if you're looking at long-term global trends, you need long-term data. And people may well be listening to this and thinking, how accurate really is this stuff from tree cores? Because if you've got hardcore empirical data from weather stations, from things like the Met Office, you can really take it down to sort of 0.0s of degrees, can't you? But how finely can we really judge this tree ring data?
Yeah, that's such an important question. So once we bring all our results back up to a computer after those fluffy bits of cellulose have been through a mass spectrometer, that's when the important work starts to test that. So what we would end up with is a value of ring width or of wood density or of a chemical parameter from the wood. And then we would go into a process called calibration. So if you think back to me describing us being in the forest coring our tree, the outside ring of that tree is 2018, and the inner 100 years have weather information from the tree for the same period that we have meteorological data. So we can take temperature data from a weather station nearby and check that the width of the ring or the density of the wood or the chemical parameter does match that temperature variation from an instrument. And that calibration is really critical to us being able to say how accurate that information is back through time. We make a lot of assumptions that tree and that species relationship with temperature has stayed stable through time. All science makes assumptions, and we need to understand them as we build them into our hypotheses. But we use that statistical calibration to define how much of the temperature variability is contained in that temperature series from the tree. And there's a little bit of statistics involved there.
And what about the unknowns, like things like, do we know that certain trees might have been subject to extra shade over time? There's lots of variable factors, isn't there? And the further back you go, surely the more unreliable this data is going to be.
Yeah, that's a great point. So we do, again, going back into the forest where we're coring our tree, there's a whole bunch of work that goes before that to try and do a bit of detective work to find the trees that are going to be most sensitive to climate. So anyone who's grown a plant in their garden knows there's a bunch of stuff that trees are plants, the same as anything, that affects growth. And climate is one of them. But what my neighbour is doing, is my neighbour growing bigger than me? Has there been a lightning strike that's taken out the branches on half of my side? Is there a bug attacking the forest? So what we do as dendroclimatologists, so as tree scientists who are interested in the climate, is search for places where there is not a lot of competition from other trees. So we might be way up at the tree line where there's one little rugged old guy hanging onto a cliff. There's no competition. There's no other trees around it. That's the tree we core. The interesting thing about tree scientists is they don't go for the big healthy guy grown in a forest. Those trees are subject to the effects of competition in that forest. We're scrambling up to find gnarled old battered trees that have been really susceptible to climate in an environment. So it is, we have to be biologists as well. We have to understand the processes in the forest and hunt for those trees whose growth is strongly limited by climate.
And final question on this. Do you ever find it difficult to convince people that, the tree records from hundreds and hundreds of years is nearly as accurate as the empirical data that you can get from weather stations?
Yeah, that's funny. That's making me remember a time when somebody did just really attack our science in a conference. And my boss at the time said, have you ever grown a carrot? Really? You think plants aren't sensitive to weather and climate? And that's kind of a good point. If you don't think plant growth responds to what our climate does, grow some vegetables. See what happens in a bad year. See what happens in a good year.
But to bring it down to the really fine figures.
Yeah.
I mean, it is complex.
It is very complex. And, trees are not thermometers. It's not an instrumental record. It's what we call a climate reconstruction. There's an entire area of statistical science that looks at how we can measure the accuracy of those records. But what's happened over the years, so one of the most important tree ring-based temperature reconstructions ever was published by a bunch of American and other authors in the late 90s, in 97, 98. And it was the first picture that we had of the Northern Hemisphere temperature changes over the last 1,000 years, mostly from trees. There were some lake records in there and that kind of stuff, but it was mostly trees. And it showed a period in the past, the medieval as being fairly static, not really that many climate changes, slightly colder periods in the Little Ice Age. And then a much, much warmer period in the 20th century and now in the 21st century as we've altered the chemistry of the atmosphere and enhanced the greenhouse effect. And that reconstruction became known as the hockey stick.
So this is Michael Mann.
This is Mike Mann, yeah, and lots of other folks involved in that study. The Mann Bradley Hughes paper in 97, 98 was the first time that we had this record. And that paper, almost the politics around that paper is more interesting than the science.
Indeed.
It led to attacks on the authors, attacks on people who worked in the broader field of paleoclimate science, and the first kind of mobilization of people who were invested in fossil fuels to try and debunk paleoclimate science. And the information in that paper has been proven again and again and again to be right. There's been various studies around the methods they use that have enhanced and improved the statistical methods that they use. But a study that involved, I'm trying to remember, I think something like 70 records, so 70 climate records from around the world from these natural archives, and hundreds of authors that was carried out by a consortium called the Past Global Changes, the PAGES consortium last year, just really reiterated again and again the information contained in that 97-98 paper that we are facing warming of a speed and of a coherence across the planet in the 20th century and the 21st century that we have not experienced for the last 1,000 years. Those results were verified again by this huge global study, and it's just testament, I think, to really just the root of the science, that we can get these really accurate pictures of past climate from tree records, and we need them to figure out how our climate's changing now and give it that long-term context.
With my historian's hat on, I wonder whether you cross-reference this scientific data that you're talking about with other kind of historical and archival data, because you mentioned the medieval warming period. I had heard of that, and I was familiar with that. I think I even read that the sort of crops and fruit that could grow in England were things that, you can't necessarily grow in the cooler climate that we've had more recently. Is there any role for things like historical data?
Yeah, for sure. So if we, I always kind of find myself thinking of climate science as a jigsaw puzzle. We've got the tree ring records in there. We've got the computer models. We've got the lake cores, the ice cores. And one of the really big pieces and really important pieces are what we call documentary or historical climate records. People have been obsessed with weather forever. There are documentary records. As a historian, I'm sure you know more about these than me. Everything from, what are they called? Rogation ceremonies, I think, religious ceremonies where people would, if they found that a glacier was advancing over their farmlands or their crops were failing in a drought or a famine, the local churches would have ceremonies to try and appease what they saw as the powers, the gods who were causing these changes. And there are records of those, so we can see when they happen, so we can match anomalous events to the records there. There are great things. The cherry blossoming dates in Japan go back 1,000 years. The timing of spring when buds burst on trees is really related to what spring weather and climate are like. One of my favorites are records of when grape harvests occurred in Central Europe. So those are just another piece of the jigsaw puzzle. And those records are super important because they're entirely independent from a tree archive or from another physical archive. And they give us a picture, and they also tell us a lot about the culture as well of that time and that period.
What role does, I think I've seen the term natural climatic variation play in all of this?
Yeah, so the reason paleoclimate science emerged, so paleoclimatology emerged, was because of an understanding that there are two components to the climate that we experience year on year. One of the natural cycles, natural variability in how our planet's climate changes over time. And layered on top of that are human-induced changes. And really the big 21st century challenge of paleoclimate science is to understand both of those components, disentangle them, and be able to define how they interact and how they work together.
Do you think this underpins some people's skepticism of the issue, that they may be aware of Michael Mann's hockey stick graph, but then perhaps they're just thinking that this is an upswing in a natural climatic variation? Yeah,
so very often when we meet people who are skeptical about climate change, there's lots of different types of people who deny climate change, I'm starting to learn. But there was definitely a group of people who, they probably have a good understanding of geography and physics that we need to understand the planet. And they are aware that our climate was colder and warmer in the past. And for them, what's happening now is just part of that natural cycle. And there's a reason for that, because we don't ever experience what the global average temperature is doing. It's impossible as a human being to experience global average temperature. We experience the weather and climate in the place where we live. So for me, I just cycled from our other campus to, so we're on our Bay campus here, and I just cycled from our Singleton campus in horizontal gale force October rain and winds, which are completely normal for this time of year. That experience, that weather that we experience every day, kind of hides the bigger changes that are happening across our globe.
Yes, because there's a conflation between weather and climate, isn't there?
There is, yeah. And so you might say, okay, well, we know that the Little Ice Age happened and we know the medieval warm period happened. But the crucial difference in what's happening now is the speed of the change and the global coherence of the change. So the medieval climate optimum, or the medieval climate anomaly, whatever you want to call it, was a change that was really internal to our climate variability. It was centered on Europe, North America, the western part of the Northern Hemisphere. It didn't have a global signal. The only thing in the last 2,000 years, the only anomaly in the last 2,000 years that has a global signal is the warming that we're experiencing now. More or less every part of the world where people live is warming. There are a couple of exceptions. The oceans are warming slower than the land. But that global coherence, that global change is not part of our natural cycle. And we can prove that in multiple ways. And the other thing is the speed at which our climate is changing. So one of the other kind of denier arguments is, we're talking about 4 degrees of warming by the end of the century if we don't adjust our emissions. There are times when the planet's been like that in the past and, species survived. Sure, but changes to 4 degrees of warming and an increase of 40 meters in sea level happened over thousands and thousands of years, not the decades that we're talking about now.
Okay, I promise I'll go on to the politics and the response to all of this in a moment. But firstly, what about you? How did you end up here? Give us a bit of an overview of your career so far.
Sure. So I always, when we get asked that question as scientists, I always feel this overwhelming pressure to talk about this kind of dedicated journey. Where I woke up at one morning at the age of 5 and knew I wanted to be a professor of geography. I stumbled into this, and I think it's actually like the opportunity to say to particularly women who are looking to become scientists now, don't think this has to be some pathway and journey that you're on that's all marked out. I was a kid who wanted to be outside. I liked being outside, playing around in mud. My family always say I was upside down and covered in mud from an early age. And so geography was, outside was where they kept the geography. So that's why I ended up doing those subjects. And as usual, as with most people, I had a very inspiring GCSE geography teacher. He was a wonderful man. I was at school in Manchester. And I then moved to Wales. And the school I was in offered geology A-level. And I thought, okay, that's another outside thing where they keep the rocks and the trees and the mud. So I'll add that one in. I was the only girl in my class. And it just kind of went from there. But I cannot remember one of these dedicated moments as this is me, this is what I'm going to do. And the other huge factor was luck. I got incredibly lucky in that a PhD came up that I was able to compete for very late. Somebody ended up getting a grant in September. And so within a couple of weeks, I had a PhD place. That was pure luck. And actually, when I talk to my supervisor now, he always says the first year he just was horrified because he was like, this girl can't write. Like, she really can't write. What are we going to do? And so I was very lucky to have a wonderful PhD mentor and a team around me. And I very slowly, over many years, learned how to do research and how to be a scientist. And it's a huge privilege to have had that experience. But emerging as a researcher, deciding to work on climate change was a more structured decision and something that I had control over.
How do you mean?
So when I started work, so my PhD was on tree rings and an emerging technology really of looking at these chemical changes from year to year. And it was pioneering really, not my work, the broader work around isotope dendroclimatology, to give it its big name. But it was quite a lonely little bit of paleoclimate science. Everyone else was working on the changes that happened in our climate 10,000, a million, 15 million years ago. Very few people actually were working on the changes the last 1,000 years. And I was surrounded by scientists who thought that was a problem because they could see that our climate was changing. And my supervisor, Danny McCarroll, I still work with him, one of the most important mentors in my career actually. He said, look, we need to be working on the time periods that are of influence to what's coming in our future. We need to be looking at the last 1,000 years. And that struck a chord with me. I was, raised with some kind of sense of social responsibility, and that whatever we're doing, it should, if it can't make the world a better place, it should not make it a worse place. And that just struck me that, if I'm working in an area of science that can actually look at the problems that we're facing as a society, these global grand challenges, I should do.
So is there a bit of politics in there then, would you say?
I'd say it's probably all politics, actually.
That's interesting.
Yeah, that I sort of increasingly have a clearer way to separate the difference between climate science and climate politics. Most of what we meet in our daily lives, most of the things you're going to read about in the news, films you're going to watch, they're not really climate science, they're climate politics. Climate science is about what happens to multi-atomic gases in our atmosphere when they meet infrared radiation rising from the surface of our planet. That's climate science. It's physics. It's about dipole moments and all of these strange little thermodynamic things that physicists who I can't talk to understand. Climate politics is what we do with that information, and the decisions that we make with that knowledge. And really, that's the only place where the debate lies.
Since your initial research and your PhD, where has all of this taken you? Because you've gone to lots of different places in the world, haven't you? Tell us about those.
Yeah, absolutely. So obviously, if you're hunting for old trees, you get to go to some old forests, and it's a part of the job that I do less now. But yeah, certainly as part of my postdoc and kind of early career years, we would spend a lot of time working with collaborators around Europe, in particular, looking for old forests. So I worked really from the high Arctic all the way down to the tropics. So
when you say the high Arctic, does that just mean up the top?
Up the top, yeah, up the top. So
are there many trees there? Sorry, I'm being very naive.
No, it's a super good question. So I spent a lot of time, certainly shortly after my PhD, working in what we call the boreal forest. So around kind of the Arctic Circle, slightly north of it, the big swathes of Europe and North America where pine trees grow. That's a great place to look for old trees. And we did some really important work up there. But a friend of mine at the time was working on a little plant called the Arctic bell heather, Cassiope tetragona, and it grows these long stems. And instead of having rings on its little stem, the rings are sort of the increments along the stem. So it grows a new leaf and a new bit of stem each year. You can measure the gap between the leaves along the branch. And she was working to try and get climate records from the Arctic bell heather. And so I got to go and work up in Svalbard and Spitsbergen, so Norwegian island, just about, I always get this wrong, I think it's barely 100 miles shy of the North Pole. But it's an incredible place. It's land of glaciers and all these incredible northern landscapes. And we looked for Arctic bell heather to see whether we could look at some of these chemical records along the stem.
Was that your favourite place to work, or do you have a favourite place to work?
It changes through time. And as with a lot of people who get to do field expeditions and things, a lot of my sense of place is risk-based. So working in Svalbard was amazing because it's such an incredible, beautiful, active landscape. There's glaciers all around you and there's amazing wildlife. We found a whale carcass on a beach that we spent like half a day looking at the bones and the tissues of. You don't get to do that anywhere else. But it's also terrifying because of the risk from polar bears. And there's a huge part of field expeditions is about minimizing risk. TV shows where people go off to adventurous places and they're always on the edge of something disastrous happening. That is the absolute opposite of what you do when you put an expedition together. I have never seen a polar bear in my life, and I consider that a success. I don't ever want to see one. I don't ever want to be in close proximity to one. But we do have certain things that we do on expeditions in polar bear country. And one of those involves carrying weaponry. You have to carry guns. And you do gun training and all this kind of stuff. And I am a terrible, terrible shot. And I'm also really not observant at all. I look at plants. If I'm walking around up there, I have my nose in the grass in the tundra. So I had a friend who was a glaciologist who came with me, my good friend Tim James, purely just to make sure I didn't get killed. And no one else did. I
can just imagine the irony of a climate scientist shooting a polar bear as well.
it's just not something that I ever want to think about, not an encounter I want to be part of. There's an entire kind of world around polar bear safety, particularly in Svalbard, because polar bears are protected up there. And actually, if a polar bear ever does have to be shot in a human-animal conflict, there's a more or less a murder trial that goes on to try and figure out what's happened and how that situation's occurred. So I consider, as a geographer, one of my greatest expedition triumphs is never having seen a polar bear. But so to ask about favourite places, I loved being up in the north but the stuff that can kill you up there is huge. I now work a lot in the tropics, so in tropical rainforest, where most of the stuff that can kill you is tiny, and it's a whole different level of things to be scared of, basically, and to risk minimise.
What are we talking here? Spiders?
Not no? The spiders. The centipedes will hurt you, and I'm also I've kind of said I'm kind of rubbish at biological observation. Weirdly, I'm not very clear on the difference between a millipede and a centipede. There's all these rules, but they seem to me suddenly I'll look at something and say to our fabulous forest rangers, I'm like, that's a millipede, right? I can pick that one up. No, idiot, that's a centipede. We've talked about this. So I'm continuously kind of thinking about how I minimize risk, as anybody is who gets to work in these incredible environments. So if you ask me now, I'd say tropical rainforest was my favorite place to work because that's where I'm working at the moment in my career. But before I would have said the Arctic. So I'm very lucky. I pretty much love wherever I'm working.
You've talked a couple of times about the people who you've collaborated with in your career. Who are you working with now, either internally here at Swansea University or externally, other organisations?
Oh, that's a nice question to be asked. So one of the joys of being a scientist, actually, probably the main joy is the people we get to work with. And I think you said at the start, I'm a geographer. That's my kind of the umbrellas over my head that describe what I do. That's the biggest one. And with kind of ultimate interdisciplinary subjects, we do everything and anything. So I work with people from Latin scholars working on those historical documentary records, to the physicists who build climate models, to biologists, geologists, oceanographers. I'm really lucky to have a really broad network of people that I work with because of this jigsaw puzzle that we need to put together when we study the climate. So at Swansea, I guess the departments I collaborate with most are physics and bioscience. Sometimes on research, but a lot on broader public engagement and outreach work that I do as well. But I do work on another project with colleagues in engineering in our Energy Safety Research Institute in Esri, looking at some of the methodological advances in how we measure tree rings. We have guys in engineering here who are really good at developing stuff and making stuff and inventing stuff. So we're working between Esri and physics and geography to try and see whether the ways that we measure the chemical differences in tree rings can be a little bit smarter, a bit cleverer, use different techniques. I have a lot of collaborators in Swansea.
Perhaps on the flip side of this, tell us about your jigsaw of weather data. I don't mean that to sound flippant.
The weather jigsaw, the mighty climate change jigsaw, as it's known. So I think I mentioned Danny McCarroll, who's a professor in geography as well. He was my PhD supervisor. So I've known Danny for years. I worked with him on my PhD and then left and worked all over the place and then came back to be a postdoc for him. And then I've stayed in geography. And Danny is the head of our research group. So we have quite a big research group of us who work on tree rings and paleoclimate in geography. And Danny is really the head of that research group. And Danny's other love, as well as being a tree ring scientist, is woodwork. So last year, Danny and Neil Loader, another colleague of mine, colleagues from Oxford University, were working on something called the UK Oak Project. So over the last 10 years, our isotope lab, through Neil and Danny and a few other folks, have figured out that a measurement which relates to the type of oxygen stored in the rings of oak trees in the UK is a really, really good measure of how wet our summers were. I can explain a bit more about how that works. And they built up a picture of how wet our summers were from this parameter, oxygen isotope variability in oak tree rings, over the last 800 years. And it was really important because it showed them that times when our climate had deteriorated, so very wet periods, had been related to really big, impactful events in our society, famines when crops failed and that kind of thing. There were other times when they could see that our summers had been dry for a long period of time. And Danny wanted a way to represent that quite complicated story with a bit of isotope chemistry in there. So he built a jigsaw. It's kind of if you imagine what a bar graph looks like, of blocks, where each block is how wet the summer was, and over the horizontal scale, 1 block per year. And it's great because there are pieces that are kind of a mystery piece, and you have to fit it into the jigsaw and find out what time period it relates to. It's a really great way to talk to people of any age about paleoclimate and what we can do with tree rings.
And particularly, I would guess, for younger people as well, which is something that you're very interested in. It forms part of your outreach agenda. So do you want to tell us more about that?
Yeah, absolutely. My favourite subject, really. So yes, I'm really passionate about science education and about making science more diverse. Despite the fact that people have been working on diversity in science and its broader STEM, so science, technology, engineering, maths, medicine as well in there. People have been working on trying to make science more diverse in terms of who felt that they could do science in school and think about a career in those areas. And it just hasn't worked. You know, for despite 20 years of investment in this stuff, unfortunately, science is still dominated by white men. And that's not good for society or science. It's kind of disastrous, actually, and kind of devastating when you look at the loss of talent from the potential there of anybody to want to become a scientist. So I'm really passionate in trying to work with particularly young people in schools and supporting teachers and supporting science education to make science more inclusive. And what I'm particularly interested in, we have a few projects that I work on with colleagues here at the university, trying to increase the socioeconomic diversity so that kids from backgrounds where there isn't a strong tradition of going into higher education, of even going into post-16 education or of going into science, just have the capacity to make that decision for themselves. So they have actually had a chance to do some science, come to university, spend some time in our lab, spend some time doing field work with us, and make that choice for themselves.
Are these organisations like Schools for Science?
Yeah, so I, with my colleague Will Bryan in physics, run a project called S4, so the Swansea University Science for Schools scheme. And yeah, just really simply, we just try and throw open the doors of the university to bring kids from areas where there isn't a strong tradition of people becoming scientists or going to university, bring them onto campus and do some hands-on science activities, tell them a bit about the research here, so they can have access to that world.
And with the theory that if the intake of people studying science is more diverse, the science will be better?
That's a really good question. I mean, yes. I think it's, for me, I'm sure that's the goal when you look at, the people who pay for education and science in the UK who are interested in productivity and prosperity. And when we lose talent and we lose the possibility of any individual becoming a scientist, we lose potential for discovery and innovation. But I'm sort of more interested in what's right for kids, really. I just think there's a lot of research, and there are people who work on educational inclusivity who look at the really negative impact that it has on a child's feeling of self-worth if they feel there are multiple avenues and multiple choices in life that they don't get to have. It just impacts every part of their lives, their self-efficacy, all these sorts of things. And I think if we can do something, Swansea University sits in one of the most deprived places in Europe socioeconomically. We were on this beautiful campus, which is half an hour from schools that are dealing with things that most of us can't imagine in our daily lives. And we need to make sure that we're connecting with those communities and doing what we can to support lives being just a little bit better, really.
And thinking of young people, school children, it's a particularly interesting time, isn't it, for you to be engaging with them? We've got school children all over the world striking, not attending their classes, over the very issue that you're researching.
Yeah, absolutely. It's one of the funniest things to be kind of on the sidelines of at the moment. I was talking to somebody about how a lot of the time people are asking climate scientists, how do you feel about Greta? How do you feel about Extinction Rebellion?
This is Greta Thunberg.
Yes, Greta Thunberg. Just such an inspiring woman. I think we're so lucky that she's built this youth movement. And one of the things that I keep thinking about is I think I was talking about how not many people were working on climate change in its modern context when I started work as a scientist. It's quite a weird little bit of geography and quite a weird little bit of paleoclimate science actually. And suddenly it's not a lonely bit of science anymore. Everybody wants to talk about this stuff. And that's step one. I am more than happy to talk with people who completely disagree with my views as a scientist and my evidence as a scientist. We just need to talk. We just need to actually get the conversations open. And that's what these movements are doing.
Is there the danger that we see too much of it? And I only pose that because I feel like, for example, on the Today programme on Radio 4, you hear a lot more items dealing with this issue. And I wonder if you can almost have information overload.
Yeah, absolutely. That is definitely a problem. And people just kind of become immune to being told the same thing again and again. I think one of the things that we really need to do is start to understand why people have very set responses. What if I do an article or an interview about climate change and I give some facts and figures, I can pretty much put people into two pots in terms of their response. There will be people who are frantically looking for an opportunity to agree with me because we all like to agree with people. And there will be people who are just looking for another opportunity to say, you're wrong, this is nonsense. And understanding their perspective and understanding why it's actually nothing to do with science is something that we're not doing at the moment. We need to. The denial of climate change comes from a political and a social place. It's not really been about the science ever. And one of the things I'm so frustrated about is that as climate scientists, we've wasted 20 years arguing about the hockey stick. And a lot of the people who had investments in the fossil fuel industry really love that we wasted time doing that, because that was time that we didn't get to the bottom of why people have genuine fears about the climate change movement. And a lot of those, I'm loath to say I sympathise with, but I am going to say I sympathise with them because I do. If you're a mum, you are looking to have a good future for your children. And probably a part of that good future is buying them things and making sure that they can drive a nice car and making sure that they can prosper. And it's possible for people who those are their priorities to think, you people want me to live more poorly. You don't want my children to have nice things. You don't want my children to have a prosperous future. I saw a line in a tweet from a climate denier. It was vicious, actually. It was talking about some of the protesters in London that are happening in 2019 at the moment. But actually it said in there, these people want global austerity for us. And I think we have to, obviously that's completely wrong. That's not what people want. Global austerity is going to happen if we don't stop our climate deteriorating. But it's really important to understand that perspective. If you're somebody who wants better for your children and you want to buy them nice things, it's actually probably quite scary to be told we want you to consume less. We've just got to get our head around those perspectives.
So with that in mind, what do you think the future holds? I know you're not...
Good question.
You don't own a crystal ball. But what do you think?
I'm going to have to break that question down a bit. So do you mean for us as a society, what decisions do I think we'll make?
What decisions do you think we need to make?
Decisions we need to make. Okay, that's a little bit easier. We as far as I'm concerned, and the advice I hear from people who are better at this than me and smarter at this than me, is that we need to rethink how we consume on a huge level. And what's actually kind of frustrating is we're already doing that. The low carbon economy is one of the fastest growing economic sectors on the planet. We're already decarboning how we produce energy. Renewables are growing. All of this stuff is happening. And we need to talk more about the fact that we are making changes. But ultimately, we can't buy our way out of trouble. There is no silver bullet. Greta's not going to save us. Some clever instant renewables fix isn't going to save us. Carbon capture and storage isn't going to save us. All of these things have a part to play. And to me, the most important thing is that whatever walk of life we're in and whatever our background, we try and think about what we can do. what I can do as a climate scientist is talk to people and try and make sure that I carry on doing good research. Somebody who's working in a hospital, someone who's a businessman, someone who is a lawyer, they have things they can do as well. And it's all, we really need that kind of choir of voices to make change.
And from that political aspect, what do you say to what I think is probably one of the most common critiques, which is that you and I can change our behaviour. In fact, most people in this country can change their behaviour. We can decarbonise our economy as much as we want to. But it's not going to stop some of the major developing nations or developed nations in the world continuing to use fossil fuels at a very high rate. And therefore, what we do, which might mean an economic hit, won't actually mean any positive good happening for the world in total.
Yeah, I mean, you're kind of digging into the big the
big politics questions, I know. But.
Yeah, of climate justice, and I think that's a really important thing to. I don't have any answers to these questions, but I do think the questions are important. The whole issue with climate change is that it's caused by the North, but it will negatively affect all of us, human-induced climate change, but it will most negatively impact poor communities in the global South. And who are we to try and limit prosperity and growth in those countries?
We've had our industrial revolution,
right,
etc.
And there's a problem. But actually, we're very, very lucky, incredibly lucky, that most of those nations have a better understanding of sustainability than our governments do. And actually, they want to put sustainable growth into their systems because they understand that if they don't, they're in even more trouble than they are now.
Including the Chinese government?
Would you count China as a developing world?
No, parts of it are still developing.
Yeah, for sure. It's
still got a lot of room to develop hugely, I would guess, which surely is a concern.
Yeah, I mean, there's concerns everywhere. There's no shortage of concerns, but and there are. I wouldn't shy away from the fact that when we have big climate conferences, big attempts to kind of get agreements on the table, there are political players and geopolitical forces in particular countries who are a problem again and again and again. It's also really important to remember in the 3 years since we signed the Paris Agreement to limit global emissions, over $400 billion have been invested in the top 10 coal plant developing companies in the world. As soon as you start to pick away at the surface, we really are not learning our lesson in terms of the problematic nature of industrial revolution type capitalism.
In which case, sorry, this is fascinating, but would it not be worth putting a lot of money, say in this country, into things that would mitigate the effects of climate change rather than trying to halt it or slow it down?
Yeah, I mean, like I said, it really is. We need everything. There's no magic bullets. We need to explore, capture, and storage. Personally, I'm quite skeptical of geoengineering. So these ideas that we can put something into the sky or into the oceans that will do something clever and suck down carbon or make more sun reflect back to space or something. And actually, that's a really interesting problem because it's an ethical question. If you want to geoengineer the planet, you need the ethical permission of every single person living on the planet to do that experiment, which obviously is not something we can generate. So, but there's no harm in carrying on investigating those possibilities. Maybe geoengineering will show up something that is applicable and we can put into place. So yeah, we need the mitigation technologies. We need renewables to be better. We need the people who look after our economies and how our economic systems work to stop supporting fossil fuel to the level that they are. If you look at the kind of economic propping up of the fossil fuel industry, it's remarkable. It really is. It's a big choir. Everyone's got a part to play.
And are you an optimist or a pessimist about everybody playing their right part for the future?
I'm by nature a pathological optimist, I would say. And I think that we as a species are incredible and adaptable. And I would like to believe that we make good ethical decisions about what to do to protect the vulnerable people in our communities, and climate change will impact vulnerable people. But yeah, without wishing to give a huge dark stamp to the way this conversation's going, I'm also the niece of a Holocaust survivor. My aunt is a European Jew. Her entire family was wiped out in the Holocaust. And I have very interesting conversations with her about the relationship between hate and climate denial. And she is always seeing parallels in how we otherize people and how we talk about people as just not being as important as us. And it frightens me and scares me because there's an underlying thread in the denial by people that we need to do something to protect our planet because it is going to, if we don't, the way our climate is deteriorating, the species extinctions that we're seeing, the collapse of biodiversity, the loss of habitats are going to negatively impact poor people away from the rich white nations. And I think those are the sort of the darkest directions that we could go in if we start to see the values war that's going on our planet right now about our future descend into the kinds of hatreds that have attacked entire communities.
That was a really fascinating discussion. Thank you so much. If you want to find out more about Mary's research, you can visit her staff page at Swansea University's College of Science webpage. For more information on her outreach work with young people, visit S4, that's the number 4, science, so S for science, all one word, .co.uk. To find out more about this podcast and Swansea University's research, visit swansea.ac.uk/research. That's all for this episode. Thanks for listening, and thank you again to our guest, Professor Mary Gagen. If you've enjoyed this episode, please subscribe, rate, and review. I'm Sam Blaxland, and that was Exploring Global Problems from Swansea University.